Good evening, Professor Benning. My name is David, and obviously you know me. So today I'm going to be showing you how my circuit works for the mod 80 or mod 79. The basic version and the advanced version. The basic version is straightforward. We have a 50 hertz clock going in and then coming out and giving you the numbers on this the digitizer, the LCD segment, the 7-segment monitor. And coming from pin 14, coming from pin 2, you have the green wire going in, perfectly color coded so you won't get mixed up. So it's going in, the clock begins here from the flip-flops. And then you have a mod 8, or well, mod 7. Mod 8 coming in, which and then the decoder decodes it and provides on the digitizer up here. So there's 3 inputs, and then the ground, and then you have the 3 flip-flops. Alright, and this is just the first one. I'll show you a quick little simulation over here. This should be the final one. There we go. Okay, so I set it to 250. Oh, whoops, this is the other one. Sorry, my bad. So this is the first. Okay, sorry. So yeah, so the simulation right now over here, you can see how the mods work. You have the 3 flip-flops over here, and then we have it set at 250 hertz, so it's not too slow and not too fast. But I'm gonna click play, and then you'll see how it counts. So it's counting up from 0, 1, 2, 3, 4, 5, 6, 7. And you see it restarts at 0. Let's stop the simulation. And let's set this to like 1500 hertz. And you can see how fast it goes. It has 1, it starts at 7, and then 2, 3, 4, 5, 6, 7. And there you go. That's the basic circuit. Right, so for over here we have the advanced circuit that I created. So basically it's the same thing as a simple circuit, except we have a lot of stuff over here, and you're probably wondering why is it so cluttered and what's the point of all this stuff. Well, basically we have 3 extra things that I've added onto this that all have to deal with the first counter over here, the counter U4A, or product U4A. So basically what this all does is that we have a reset button over here, and we have time changers over here. So A and B changes the time. A changes the time for B changes the time to number 5, and A changes the time for 3, and I'll explain that in a second, so it seems pretty confusing. So when the voltage is coming in through here, you have voltage coming in through here, and then you have this has to be 1 and this has to be 0 for this to constantly always be 1. So it's an XOR gate, or XOR gate. And we have constantly 5 volts coming in through here, feeding into every single flip-flop. Although, if you want to reset the flip-flop, for example, if it's at 3 seconds, 6 seconds, 7 seconds, or however you customize the circuit, if it's 50 hertz, 80 hertz, depending on how you customize it, you might want to hit the reset button. So you hit this reset button over here, and obviously what the reset button does is that it resets the circuit. And that's over C right here. And second of all, we have the AND gate over here, which is basically this AND gate limits the time. So obviously we know that this is a mod 79, although we can make this, or a mod 80, and we can make this into a mod 50. So what that means is that this can change this. So if I'm at, for example, if I want to keep the counter going to only 50, then I would hit B, and then it would only this would only change until 50, or this would only go to 50, and then it'll reset when 50 hits. And then obviously same thing with A. You see it's connected over here to flip-flop 1 and flip-flop 2. So when flip-flop 1 and flip-flop 2 are activated at the same time, this only goes to 3. And when 30 activates, or when the flip-flop counter hits 30 or 3, then it'll reset. And I'm going to show you how that works. Alright, so basically, due to technical limitations, the push buttons don't actually work, so everything is gonna have to be done manually by using actual wires and 5 volts. So I'm just gonna delete the push button here, and then I'm gonna connect this, acting as the reset button. So I'm gonna connect it here, and then pretend that's a push button, pretend that's a 1 and 1 going in, and then when you see here, the circuit won't start at all. So it'll just constantly be going up and it'll be constantly at 0. And then obviously I can't really, the push button just doesn't, it's not real, it's just decorative. But if I put the push button back in, if you start it, it'll go back to normal as if it was a 1 and 0 going into the XOR, which would come out as a 1. Alright, yeah. So you can see here, C pretty much acts like the button, the reset button or the push button you saw in the diagram before on the multi-simulator. So it's the same thing. And basically, yeah, you see it's acting normal again as if it was always on. And the push button has to be off, or the reset button has to be off for it to work. And then over here you see the actual, the changers, the time changers. So same design, pretend it's hooked up to a push button, but those push buttons don't actually work. And then now we're going to basically delete that, and then we're going to make sure the counter only counts to 5, and then when the counter counts to 5 it'll reset. So I'm going to push and pretend that the button's being pushed, so I'm going to move the line so it's 5 volts coming in into the actual AND gate, as you can see here. And let's see, you'll see it'll count to 5 and it'll automatically reset. So 1, 2, 3, 4, and then 0. See, it resets. Okay, stop the simulation. And then we're going to do the same thing as for here. Delete that, and then pretend the push button acts like it exists, but actually doesn't. And then this, we're going to count to 3. And when the simulation counts to 3, we can see that it'll automatically reset. Oh, okay, there we go. Yes. So the simulation will reset, or sorry, the counter will reset when it hits 3 or mod 30. So this is cool if you want to set it to 5 seconds or 3 seconds or however you want to set it to, it'll automatically reset. So, and then the LEDs just dictate like the code and the signals that actually go through. So, alright, so basically we have everything ready here. So like I said, this time we're now going to be using this U13 and 2 AND gate. So now this time when the digital clock counts to 3, it'll reset. So this is obviously shown from the AutoCAD document over here. This is simple advanced. Okay, shown by the AutoCAD document. So over here, AND LS08. So this this AND gate over here will be only activated when you hit A on your on the logic board or logic monitor board. So let's test it out. So we hit play simulation. We can see that it increases to 1. We have LED here, 2, 3, and it resets. 1, 2, 3. There we go. Oh, 2.9 or 29, and there you go. We have that working all perfectly. Last of all, yeah, that seems pretty much it, and that's exactly what those two do, or what these. Oh, sorry, that's my video editing software. That's how I edit the videos. Why can it not come out? There we go. And yep. So this is the reset buttons right here. So they're activated by A and B. A activates 3 seconds, and then B activates 5 seconds. So the timer will only be able to go up for 5 seconds, etc. And these are the clocks. These aren't actually real. I just designed them really carefully. Pretty awesome. And yep, that's all. Thank you so much, sir, for watching, and I hope you have a great semester. And be safe, and God bless you, and thank you so much. Have a great day, or have a great year, and maybe I'll see you next semester. I don't know. Alright, we'll see you, sir. Thank you.